In today's video, we are going to see how we can implement chat memory in case of our Spring AI apps. But before we deep dive into the implementation, I would like to showcase you the problem that we face when the chat memory is not available in case of our apps. So here I have created one simple Spring Boot application to interact with the LLM. In our case, it will be Gemini. So here we have the API chat endpoint, and when I'm sending the first question, so it is replying with some content. Now when I ask the follow-up question, what's my name, in that case we will get some response stating I don't have a memory of the past conversation. So this becomes frustrating when users are interacting with the chatbots wherein they are not able to remember the past conversations that the user had with the chatbot. So in order to solve the problem, we have to implement the chat memory so that the LLM is able to remember what all conversations we had in the past. So let's first try to understand the application that we are trying to build. So here you can see in case of pom.xml we have added two dependencies. First one is the Spring Boot starter app. With the help of this we will create the simple REST endpoints, and second dependency is Spring AI OpenAI dependency, which is useful for interacting with the LLM. So and that inside the dependency management section we have the Spring AI bomb, which is useful for managing the AI related dependencies. Now coming to the resources, here you can see in order to interact with the LLM we have to provide some basic configuration like our API key, the endpoint or the host with which we are going to interact. In our case we are interacting with the Google Gemini, due to which we have provided the path related to that, and the model LLM model which we are going to use is the Gemini 2.0 Flash. So coming to the configuration part, so in order to interact with the LLMs we have to make use of the chat client, using which we can send the messages to the LLM and receive the response. So here you can see we are creating a bean of chat client. Now in order to implement the chat memory we have to create the bean of memory also. So in our case we are creating the in-memory chat memory. What it means is it is going to store the conversation history within the memory. You can think of it as a RAM. So whatever conversation that user and LLM will have, it will store all that information within the memory itself. Now in order to configure the chat memory within the chat client, we will have to provide some information to the chat client. Here you can see we are adding the advisors. When we say advisors, these are nothing but the interceptors that are used to add some useful information in case of request and response. Basically these are used to perform some additional functionality, and in our case what additional functionality we are performing is we are adding this memory support inside our application. So we will have to add default advisors, and the whatever memory we have created in memory chat memory we will pass it. Now in order to manage the chat memory we have the message chat memory advisor. So whenever the conversation will go back and forth between the user and the LLM, so all that task will be performed by the memory chat memory advisor. So within which and those conversations will be stored within the chat memory. Now coming to the controller, here we have created three simple endpoints. First one we already seen, like the API chat endpoint, which is useful for interacting with the LLM. Then we have created the next endpoint, which is the history endpoint, and these are just for the debugging purpose in order to see what all conversations that are available within the memory. And if we have to clear the memory, we have the delete endpoint. Now coming to the first endpoint, so here you can see the chat client that we have created, we are making use of that, and similarly chat memory also we are importing here so that we can see the history or clear the history if we want. Now coming to the first endpoint, which is the chat endpoint, here you can see we are making use of chat client, and then we are sending the input that we are receiving from the user, which is nothing but a simple string. Then we are making a call to LLM, and whatever content we are receiving in response, we are sending it back to the user. Now we have implemented the memory inside our application. Let see one demo. So the application is started. Now we will hit the same endpoint. We will provide the same input to the LLM. First is the simple hello message, wherein LLM is replying with some response. And now when we send a follow-up question, we will get the proper response. Hey, now so you can see the LLM is replying properly, because the chat memory is properly implemented in our case. Now in order to see what all content is stored within the chat memory, we have the history endpoint, right? So when we send a request to the history endpoint, you will see whatever conversations we had with the LLM till now are stored, including what user has provided the input and also what response we have received from the LLM. So first message was, hello, my name is Banti Ragani, and then the reply that we received was, it's nice to meet you, how can I help you? Then I sent the follow-up question, what's my name? And then we received a response like, your name is Banti Ragani. So this is how the conversation is maintained within the in-memory that we have configured within our application. Now coming to the third endpoint, which is useful for deleting the memory. So here if I am performing the delete operation, here we are just getting a static response which we have added in the controller, conversation history cleared. Now if I call the history endpoint, here you will see the entire chat memory was cleared. And also when I ask the same question now to the LLM, what's my name, it will say, I don't know this information. So here you can see LLM is saying, I have no memory of the past conversation because we have cleared the memory. Now coming back to the controller, here you can see in case of history endpoint and delete endpoint, we have made use of something called as default. This is nothing but the ID with which our conversations are saved. So by default, Spring makes use of the default as the conversation ID. So while fetching the conversation, we have to specify the conversation ID for which we want to fetch all those responses. So that's why we have given the conversation ID as default. Also, while clearing the memory, we have to provide what memory with what conversation ID you want to clear. That's why we have given the input as default. And last n denotes how many recent message you want to retrieve from the memory. So when we call the history endpoint, it will search the memory for memory with conversation ID as default, and it will fetch recent 100 messages from that particular conversation. So this was all regarding the simple in-memory implementation. Now you might have noticed one problem. The entire conversation was getting maintained with the same conversation ID, which is default. What if your application has the multiple users? This is where we have created another controller in order to solve that problem. Let's say your application has multiple user, and for each user you want to maintain a separate memory. This is where this solution will come handy. So the controller is almost same what we have seen earlier. We have just added one additional configuration which we will quickly cover. So here you can see we have API, the endpoint is API users, and as an input we accept the user ID as an input, and we have created similar chat application. So from path variable we will get the user ID, and similarly from request body we will get the content whatever we want to send it to the LLM. The only difference you will see here is this, wherein before sending a request to the LLM, what we are informing is to the advisor is that we want to maintain the conversation ID based on the user ID that we are receiving in input. This is nothing but for each user a separate entry will be created within in memory. Let's say for user 1, a separate memory will be created. For user 2, separate memory will be created. So this is how you can solve this problem. All you have to do is you have to specify one parameter, which is chat memory conversation ID, and you need to provide some unique key based on which you want to maintain the separate conversations for each user. In our case, it will be user ID. User ID we will be receiving from the path variable. The rest of the endpoints are same, like the next one is to get the history. So based on the user ID, we will get the conversation history, and we have specified we want to retrieve last 100 messages. And in order to clear a conversation for a particular user, we will accept user ID as an input, and we will clear the conversation ID for that particular user only. Let's see this example in action. So just a second. Here we have created the endpoint for the multi-user. You can see API users, and we have two dummy characters named as Alice and Bob. So for Alice, I am sending the first message. Just a second. So now the LLM has replied. Now when I'll fetch the history for the Alice. So here you will see we are getting the response. My name is Alice, and it's nice to meet you. Now similarly, we will create. Now the Bob is coming. So Bob will say hello. My name is Bob, and LLM will reply with the greeting. It's nice to meet you. Now when we can see the history for Bob as well. So when you see the history for Bob, hello, my name is Bob, hello Bob, it's nice to meet you. Now what we will do, we will delete the history for the Bob and see what are we getting the response in that case. So conversation history cleared for the user Bob, and now when we fetch the history for the Bob, it is showing as empty. But now if we fetch the history for Alice, you will see that particular history is still maintained, which shows that behind the scenes we are creating the separate memory for Alice as well as Bob. Now when we ask the question to the LLM, what's my name, this is for the Bob. Now LLM will say I don't know you, so I don't know your name. But similarly, when we ask the same question for Alice, we will get the response, because for Alice the memory is still intact. So here you can see your name is Alice, you told me just a moment ago. So that was all regarding the chat memory, how we can implement it for a single user, or if you want to maintain the separate chat history for the multiple user. This is how we can implement the same. Also we have created the blog on this, wherein we have specified each and every detail, including the code that we discuss. So you will find it here, and the implementation example that we discussed in our demo is also present on GitHub. You can go and check out the same if you are interested. Yeah, so that was all regarding this. Thank you.